Great. Well, thank you very much for coming to listen to. Who wants to come out on a Tuesday night to talk about code reviews? I'm impressed there are so many people. So I'm assuming that you're just really coming here to tell me that you don't agree with me and you think they're a pointless waste of time. But I'm hoping that I'll be able to persuade you otherwise. So yes, tonight's talk is code reviews. Are they worth it? But clearly, I think they are. Otherwise, I wouldn't have spent all this time thinking up a talk to talk about them. But I'm wanting to look at how you can find the value in a code review. Code reviews take time. Code reviews take effort. So there's a cost to them. So there must also be a value to offset that cost. And I'm going to try and. Clearly, the TV doesn't like code reviews either. Pause for the technology.
One's up. Loading.
It's bound to want an update now as well, isn't it? The suspense. HDMI 1, that's a good sign. Yay! Right, I'll stop waffling then. What I want to look at is what should a code review be? How can you approach the ideas of code reviews? How can you get the best out of them? How can you get something out of them for your effort you've put in? I will also look at. I'll go through the slides in the right order. Firstly, I'll tell you a little bit about me. You can see my happy smiley face. I'm a senior engineer at a company called Sedex. We're based in London, but we're scattered all over the place. It's an ethical supply chain auditing and analysis company. We work for supermarkets and things, and we check back in the supply chain of all the things that you buy from supermarkets, and we look at their ethical sort of labour practices and their environmental impact and that sort of stuff. And so when it says ethically supplied, we're the people that prove that for those. I have a whole bunch. I'm currently using Kotlin and Java. I'm mostly sort of JVM, but I have a whole bunch of other languages that I've played with and used in things in the past. I also have a couple of side gigs, because we've all got side gigs, right? So I thought I'll put them on the slide as well. And they're fairly diverse, but if you're interested in Scottish Gaelic or you're interested in local history, come and catch me afterwards and I can tell you more about each of those. Quite a lot, in fact. What are we doing here tonight? Why are you coming to listen to me? Well, I want to look at code reviews, but I have to start by thinking of what a code review actually is, and in practice what it isn't. Then I want to look at where they fit into the engineering process, into the process of creating code and the process of building things. How do they fit? Where do they fit? Where do they not fit? And how do we work? How do we work around this concept of a code review? Then I think there's some things that you can do to prepare for a code review, to prepare to get the most out of it. You can't just turn up and have a go. You need to think about it in a few different ways, and there's ways that you can help yourself with that. Then finally, I'll go through the meat of it is when you're actually doing a code review, how do you get the most out of it? So, starting with our first bit is, what are they? Well, I'll start with what they're not. A code review is not a pull request. They are not the same thing. They're often thought of as the same thing, and you will use the same process, you'll use the same tools, but PRs were originally invented for open source projects where you could ask anybody out on the internet to create some changes or some updates or some bug fixes to your open source project. You've never met them, you will probably never meet them. You have no idea who they are or what their agendas are or what their skill levels are. All you get to see is the code, the diffs, the patches that they're putting through. So you need to gate check it. You need to, it's your open source project. People are relying on that. So you use a PR as a quality gate to make sure that you are happy that what is going into your code is safe and applicable to use from somebody you've never met and probably shouldn't trust straight off the bat. But in the companies you're working with your colleagues, you probably trust your colleagues. Otherwise, why did you employ them? You probably understand how they work. You probably know what they're going to suggest. You know their coding styles. You know the way they work. You don't need that quality gate to make sure that they're not trying to sneak backdoors into your code. But that doesn't mean to say that a code review can't have value to both you and the process and the code itself. You just don't need that as a quality gate. So there's different ways of looking at it. The way you would look at a PR, the way you look at a code review. A code review itself, what it is a dialogue between two engineers. That's basically what it is. It's a discussion. It's a discussion about the choices that have been made, the decisions that you've taken when you were writing that piece of code, exploring the various outcomes that you've found and the outcomes that were expected by the person reviewing it. It's also a learning opportunity because if you're writing your code and you're giving it up for review to somebody else, you're finding out what they know and what their particular view on that particular piece of code is. But if you're reviewing it, you're also looking at somebody else's code. You're seeing how they've done things. They're different from you. They've had a different upbringing. They have a different way of coming into the industry and learning how they've learned what they've done. They've got different ways of doing things. So it's a great opportunity to find out new stuff. And yes, it's a second pair of eyes, just to check if you were particularly looking at one area and somebody else is like, "Oh, I've seen this before." It's somebody who's got your back. It's somebody who's going to protect yourself, and that's what you want from a teammate. So we looked at what they are and what they're not. Then I said we'd have a look at where they fit into the process. So let's have a look at the engineering process itself. You may recognise these. What we're probably mostly used to, I don't know about you, but quite often we'll be working in a Scrum team. We'll get chunks of functionality in a ticket. So I'll grab a ticket. I'll read my way through it. I'll create a feature branch. I'll work on it. I'll put some tests in. I'll add some more code. Then I think, right, this is ready to go. So I'll create a PR, and I also apologise. I will use the word PR and CR interchangeably because, let's face it, we all do. But I've got my disclaimer right up front. So I'll create my PR. I'll create my code review. I'll submit it to my colleagues. They're scattered around the world. I'll probably pop a message in Slack saying, "Yeah, somebody have a look at this." But obviously, it's very async. People aren't going to instantly drop everything they're doing to look at my PR. Or if they do, then that's a massive context switch for them, isn't it? So they're stopping everything they're doing, picking up mine, then they're spending some time looking at my code, and then big context switches. It'll take time to do that review. While they're doing that, I'm not sitting doing nothing because I'll get bored and I'm a coder. I want to code. So I'll pick up another ticket. And I'll start working on that. And then they'll spot something and they'll say, "Hey, Graham, what about that bit?" "Oh, good point." And I'll answer the question. And I've context switched again, and then I'll have to get back to it. And there's a whole set of studies on the huge amount of time it takes to context switch from one thing to another. It's at least 15 minutes to get back to where you were. And if you're into some serious coding, it can take half an hour to get back to that place you were at before you completely thought about something different. So you've got this cyclic loop. People can quite rightly argue it's a very async process. It's very inefficient in time because you get this chopping and changing. And quite often that means people hate code reviews. It's not the code review that's the problem. It's the engineering process. It's how you're fitting them together. It's just how you're doing it. So I'm going to argue it's not the code review that's the issue here. It's your engineering process. What other alternatives are there? Well, Dave Farley and the modern software engineering crew, the completely opposite idea is where you don't do any feature branches. You're committing direct to trunk. You're committing direct to main. You've got very small changes. You're pairing up on everything. and you use it. Well, we got here. We've got studies show, particularly Dave Farley's highlighting these studies, that if you look at key high-performing teams that get lots of things done and get high-quality code and stuff, they're producing lots and lots of PRs, lots and lots of changes, lots and lots of deployments a day. They're not saving things up and deploying once a week. They're deploying to production multiple times a day. And they're doing it because they're mobbing on things, they're continuously creating small changes and deploying, but not releasing, so using feature flags so that you can still make sure that you're not showing anybody anything until it's ready, but you're testing on production, you're having full CI/CD, all that kind of stuff. But you're still doing code review. Now, it might not look like you are because you're not creating a PR, you're not waiting for someone to review it. But if you're pairing up, or if you're mobbing, if you've got 3 or 4 of you on a call, all looking at the same piece of code, in practice, only one person's typing. Because, I don't know if you've ever tried using these tools that allow 2 or 3 people to type at once, but it's carnage. One person will be driving, but you've got 2 or 3 people who are saying, oh, what about that bit? And they might be checking something on the second screen, or saying, oh yeah, what about this bit? You are going through the process of code review continuously in that pairing session, in that mobbing session, all the time. And the same key things I'm going to talk about, to make a good code review, you're doing this all the time. This same checklist, you can go through this because you are reviewing that person's code as they're typing it. And then when you hand over, it's the same the other way around. So again, different way, different engineering approach, but the same need for the same sort of reviewing of code, if we give it a different name. And I felt like I need to put this in because what LinkedIn page does not have those words at the beginning of it? I'm vibe coding. Do I need code review? Good Lord, yes. Even more so, because again, I don't know how many of you had a go at this. The agents, they'll come up with some clever stuff, but they hallucinate. I love the fact that we've come up with a whole word for the idea of completely getting it wrong, but we've given it a term. So you absolutely need to review everything these agents come up with, because you have no idea whether one time it's going to slip in some complete gibberish that might also build and run the tests. But it's absolutely not what you want to do. And also, I don't know how many of you have seen so far the updates and the reports on vibe coding from a greenfield spot for I need a new thing to do a thing. That's relatively straightforward. Asking an agent to say, there's a really tricky bug in there somewhere, can you find it for me? Good luck with that, because they're not quite that clever. So, absolutely, you need to code review anything that agents come up with, because basically, it's the same process. You're pairing up. You're pairing up with an engineer that you've not met and you don't know the skills are. And we've got some great junior engineers who are really good, and they can talk you through what they're up to. Agents are nothing like that level. Agents are coming up with, you can give them really specific instructions and get what you want, but you need to check. So again, the same rules that I'll be talking about with code review, you absolutely need to do the same thing for the agents. In the real world, I don't believe any of you could do any of just one of those 3 ways of engineering. You will probably do a bit of all of them. You need to, you will have some asynchronous process. You might be pairing up. But even if you're really into pairing and mobbing on things, some of my colleagues are spread across multiple time zones. So, they're at work when I'm having my breakfast, and I'm still finishing up when they're off and out having their tea. So that's just not an option. And also, you only, I don't know if you're the same as me, but you only have a certain amount of emotional energy, and I can't pair with someone all day. I can't spend 8 hours with 2 or 3 people. I need alone time to code. And sometimes I need alone time to think about things. So it's going to be a combination. It's going to be, we will be getting together for maybe a kick-off meeting at the beginning where we're all talking about things, and we'll have regular catch-ups. But not everybody can do, not every organization is comfortable about everybody pairing all the time. And so the real world, it's some compromise. So how do we get the most out of where we are now and where we need to be? I said there's some things that you can do to prepare. I'm sort of building this up again. You can see I'm sort of building this up to the climax of how to actually get a great code review. So I'm hoping it's working. There's some things you can do to say, how do we set the ground? How do we lay the ground for a good set of code review process? To go for a little bit of sidetrack at the moment, I used to work for a construction company. I did IT stuff, but I still would go out to sites and I would take my site hat, my high vis, my sort of boots, my gloves, because they won't let you on site without these things. And it's not because I'm massively accident prone and I am going to walk around and bang my head on everything as we go. It's because they know that sometimes things swing or things, there are things that you can bang your head on. And if you're wearing a hat, it will cause you a bit of annoyance. If you're not, it'll take you to hospital. High vis, you wear your high vis so that trucks can see you and they won't run you over because it's muddy and you might be covered in mud and it's raining and these trucks are where the wheels are higher than my head. So they probably see me, they probably won't run me down, and I probably won't stand on the road while they do it. But if I wear a high vis, they know that I won't get stabbed. The studies prove that I won't get killed. So put these things on, and I've never needed them. I've never banged my head, I've never been nearly run over, but I wore them anyway because I knew it was a good idea to do so. Why am I telling you this? Well, in IT, we have the same process. We have a whole bunch of tools. We have a whole bunch of tools that can do the same things for us. So, static analysis. Run these tools over your code before you merge it, because humans are quite bad at seeing these sort of tiny details. You've all seen these things on the internet where they repeat the same word twice at the end of one line, at the beginning of it, and people just don't see it because your head edits that out. Whereas a machine will spot that because the machine has, it's built to do that sort of thing. It's really good at looking at these nitpicky details that humans aren't great at seeing. So tool up for this. Get yourself some code analysis, static code analysis. Use code coverage. Now, I know there's lots of debate about 100% code coverage sometimes isn't what you're aiming for. But also, if you're only going for 60% code coverage, which 40% are you leaving out? And why? These are just tools that can help you point to issues that you might have. And they're like your site hat. They'll stop you banging your head. They'll stop you going to hospital if you bang your head. Mutation testing is a great one. I don't know if you've tried mutation testing, but it's really, really annoying until it saves you from a really nasty bug that you didn't notice. And then SCA tools can spot issues in libraries that you didn't even know you had because they're not your libraries. So tool up for it, use your safety gear, and you don't have to worry about that sort of thing. And then you can spend human effort, you can spend real effort on the bits that matter. What else can you do? Well, shift left. We always talk about shift left and nobody properly explains why. What I'm meaning here is spend more time talking about the functionality that you're looking at. Talk about it up front before you code. Get together, run through the change itself, split it down into smaller units. A story should always have deliverable value, but that doesn't mean you can't have lots of subtasks underneath that. And the more you discuss amongst yourselves how you want to build this, you can narrow this down into steps that you might want to. You can design in front of Jira, I apologize, but you can build these tickets, you can narrow this down, and before you've even started writing any code, you already know what it is that you want to achieve. And if you look at the TDD sources, that's the first bit. That's the first bit before you get to the T. In order to create a test, you need to know what it is you need to achieve. And if you've already discussed this, it makes TDD dead easy. I'm also talking about splitting things down into smaller and smaller pieces because big commits are bad. And I'm just going to say that because they're awful. The bigger the commit, the time taken to understand it, to read it, to follow it, it's exponential. It's not linear. So, a 10-file change, you can work your way through that. A 20-file change, that's going to take you 4 or 5 times the length of time. 40-file changes, forget it. You're never going to actually get that understood and in your head. And I've seen people trying to push through 150 files of change. Now, I'm not talking about the thing where it's one tiny refactor of where you've changed, where you've renamed something and just happens to have touched 100 files. That's fine. But anything more complicated, anything of that size, you can't do it. It's not physically possible to actually review anything that size. So break it down into smaller and smaller pieces. And if you get to the point where you can't break it down, have you understood the problem properly? Maybe you need to take another step back and say, why do we not think we can get this out of this big chunk, this big amorphous change that we think we might have to do? We need to think about this some more. We need to break it down. This is just too big. It also, this discussion, this process, this talking things through, gets you used to working with other people, gets you used to that process of pairing up, mobbing up on things. And even though you're having a discussion, the next small step is then actually to code it together. And then you're getting more used to mobbing on things and you're getting closer towards that idea of continuous code production, continuous review. Measure to improve. There's always a measurement slide in these things somewhere because managers love a measure. What I'm saying here is if you're doing agile and it's then a process of you have your sprint kickoffs, you have your regular stand-ups, then you have your reviews and your retros. When you get to that review or retro, it's maybe a couple of weeks later from something you started up. If you've not recorded what it was that you were doing, or recorded the sizes of the commits, or the sizes of the work, the effort, if you've not set up these metrics, you've got a feeling about, this didn't feel great, or I didn't enjoy that a lot. But it's all a bit emotional, it's all a bit fluffy, it's a bit wishy-washy. If you've got numbers we have started reducing the size of our commits, we've increased the size of our turnover, we're getting more and more deploys a day, then you've got numbers to back up that process, that way you're going about it. And if you're starting a different way of approaching code reviews and you baseline yourself, then you can show to manager, you can say, we might need to take some time, we might need to go a bit more slowly at the beginning to speed up later. Managers will be much happier if you can show them some numbers and say, this is where we were, this is where we now are, this is what we've done, this is how we've improved. Then they'll trust you much more next time you ask them for an initiative, you ask them for some time for some tech debt, or you ask them for, we need to take time to build this thing. And it will be good in the long run because you've proved, you've shown that you can deliver the numbers and you can deliver this improvement and you've got the numbers to prove it. So come up with some ideas. Now, the good bit. I've split this into 2 halves. You can start off by how do we reap the value? How do we actually do the code review and get this value from the code itself? Well, I started writing this a few years ago because I felt I was really bad at doing code reviews. I didn't really know what I was doing. Someone would say, can you look at my PR for me? And I'd say, well, I can, but what am I really looking for? And I felt really uncomfortable saying, well, that doesn't look quite right. But I didn't have a process for looking through this. So then I went through all the literature and thought, I need to do some of this. And I built this checklist of a whole bunch of things I should look at. And thought, I'm never going to be able to see this all at once. So I crammed it abbreviated and truncated and put it so it was onto one sheet of A4 in a whole bunch of different columns and thought, this is still way too big. Am I going to look through each file for each of these things? Or am I going to look through for each of these things off the whole file, the whole set of files first? It just didn't feel like a process. It was just a checklist. So then I went back through and thought, well, how would I group these together? And I love rules of three. I do a lot of photography, and there's those rules of three. And yeah, there's rules of three everywhere for some reason. So I did the same thing. I split this down and asked myself 3 questions about the code that's in this review. Is it correct? Is it quality? And is it maintainable? And pretty much everything on that checklist fitted into one of these groups. So I'll now go through these groups. The first one, is it correct? This is, does it do what it should do and not what it doesn't, not what it shouldn't? So this is your second pair of eyes. This is the code that's going in, does it contribute, how does it contribute to the code base? How does it contribute to the other things around it? Does it play nice with the existing code? Does it enhance the existing code? Is it a bit jarring? Are there other paths through the code that they've missed? Because I've done that. Yeah, if there's some if statements or sort of case statements, are there other ways through that they haven't thought of? Is the logic sound? Sometimes that if you're coding it up, you might get fixated on a particular piece of that code and not see a whole other branch that the person reviewing it might do. So these are the sorts of things to look at. And also exception handling, error handling. Does it make sense? Have they caught all the errors that you could think? Is there a good approach to error handling? So that's the sort of thing that I would look for under that hat. Different people come at things from different views, different angles. So you might spot something that they didn't spot, and particularly for assistive agents, you've got no idea what angle they're coming at it from on that particular day. So you definitely need, this is a key area there. I've mentioned it, if you're coding this up as a particularly tricky problem, you might get fixated on that particular detail and miss something else. And it takes someone with a fresh pair of eyes to come and have a look at that. And that's where this. So you want to look at if you're approaching a review with that in mind, start off reading the ticket itself. Does it actually do that? Is the functional requirements met? If it's got acceptance criteria, have they been met? Have they got all of them? Bounds checking, range checking, error checking. We've talked about those sorts of things. The second question, is it quality? This is probably the biggest one, I think. I then subsequently split things into 3s. To me, quality from a software point of view is about testing, it's about security, and it's about resource hygiene. Hence, pictures. Testing, so code coverage. I know it's got a bad rep, but it's a great place to start. If things haven't been tested, why? If things have been tested, have they been tested properly? The code coverage report will just say if they've been exercised, but not necessarily if they've been properly exercised in terms of, again, range checking, bounds checking, that sort of thing. So read through the tests, you should spend as long reviewing the test code as you do the actual functional code, because it's just code. And often the tests themselves will tell you how the person writing it was thinking at that time. And have they got lots of tests on one area and nothing on someone else? Did they get fixated on one bit? And is there a gap that they've missed that you need to, between you, have a look at it? You've also then got daft things like naming standards. Sometimes that really matters. Somebody can give a name to something and it means something in the domain that you've got. It might mean something completely different to someone else, and it can be really confusing. So naming is really important. Naming is really hard, but naming is important. This is the sort of bit where I'd look at that. Mutation testing, up-to-date frameworks, all that kind of stuff. Security, this is much more on the application security level sort of area. So OWASP top 10, is it breaking any? Do you know what the OWASP top 10 is? No, nobody ever does, but you know where to find it. You can look it up and you can say, is there a possible injection here? Is there a credentials leakage? Is there sensitive information leakage? Things like stack traces, or printlns, or sort of console logs. Is there a possibility that somebody's personal information might get spewed out onto the JavaScript console log? Because that'd be a bad thing. And passwords, tokens, all that sort of stuff in code. Hopefully you've got, when you're in the safety procedures we talked about earlier, the safety tools, hopefully you've got some secrets checking and some secret scanning. But if you haven't, or if the secrets of secret scanners missed it, look out for tokens, that sort of thing. Then I talked about resource hygiene. Resource hygiene, things like closing resources, inefficient logging, optimizations, other recursive looping that when you don't need, all that sort of thing. Is it using up more energy than it needs to? Are there obvious inefficiencies in there? Because extra loops means extra energy, which means extra carbon monoxide, carbon dioxide, and extra water usage as we now see as well. Caching, thread safety, all this sorts of thing. It's a really difficult area, and you probably won't spot everything. But if you're thinking in that mindset of how do we look at resource hygiene for this piece of code, you might spot some extra bits, and you'll leave the code better than you found it. Topic 3, is it maintainable? Now this is, I don't know if you're a follower of Uncle Bob Martin and the Clean Code crew. This would be his favourite. The first topic there is, in 6 months' time, or in fact even in 2 months' time, if you come back to this code, will it be nice and easily readable, or is it going to be a horror story? Will this make any sense to you? Will it make any sense to anybody else, but will it make any sense to you? Because I don't know about you, but after I look at a piece of code that I wrote 6 months ago, I can't remember it. I've done stuff since then. I want the code to be nice and straightforward, nice and easily readable. It should be nicely structured. It should flow from one place to another. You shouldn't have to jump around. I know that we can do command click, but if the code in the classes is written in a standard form, whether you put your variables at the top, variables at the bottom, or whether you put your biggest methods and the privates at the bottom, however you do it in your team, have a process, have a standard, and stick to it so that everybody knows where to find something. And it's a nice, simple, it's like reading prose, it's like reading a book. And there are suggestions that you should be able to start at the top, read how it works, and then more detail, and then the nitty-gritty at the bottom. You're working top to bottom because that's how we're used to working out. That's how we're used to reading things, how we're used to understanding things. It's nice and easy, and you're not having to spend cognitive effort working out what the hell this piece of code does, because you've got plenty of other things to spend that cognitive effort on that will give you more value, other than just trying to work out which bit comes next. And is it fragile? Fragility is a strange thing, but we used to talk about fault tolerance, so that if it broke, you could fail over to something else. Now we talk about fragility and anti-fragility and robustness. How much pounding can this piece of code stand and still do what it should do? More than that, the tests. How much flexibility is there in the setup you need for your tests for them to work? Or do you have what are called flaky tests? Now, a flaky test is just a broken test by a different name. In fact, it's a difficult broken test because it's not always broken, although it is basically broken. If it's flaky, it's not right. You should be able to have repeatable and reliable test results. And if there's a race condition somewhere, or if you've got unexpected test data or something, then it's not a problem. It needs fixing. It's too fragile. So it's going to cause you additional effort and additional stress, and it might even trigger a P1 at the wrong time at 3 a.m. and you don't want that. So how fragile is this code? How solid? How reliable is that code that you're working through? So hopefully, after having been through those, or asked yourselves those 3 questions about this piece of code, you'll be happy that you've got some good quality there, you've got some real value out of that for that particular commit. What I'd like to argue is that this whole process that you're going through, this whole process of looking at it, doesn't just add value to that piece of code. It can also add value to all the pieces of code. by upskilling your team and building a stronger team. It's all about the feedback. It's the way you use this review and the way you deliver that feedback. And this is a really neat thing that somebody introduced me to some while ago. This is to do with actionable quality feedback. This is how you tell somebody something. There's clearly something not right with this piece of code. How do you deliver that news? How do you give them that in an actionable, appropriate, and effective way? It's not just saying, this whole commit is just a pile of guano. It's rubbish. You're never going to make a coder. That's very general negative feedback. There's nothing specific in there. You can't say, well, how do I get better? No, you're rubbish. You're never going to make it. So it's really general. It's negative. It's a club. It's just a club to beat you with. There's nothing useful in that. There's nothing you can take away from that. But if there's a particular problem with a particular area, and you say, this particular loop, if you get this particular set of circumstances, it's going to iterate forever and it'll use up all your heap and it'll crash. Can you fix this, please? That's really specific. It's negative because it's not right, but it's specific. You can work with that. You can say, I can see that. I didn't see that. I didn't get that, or I missed that. It's a spade. It's something you can build with. It's something you can work. You can create stuff with a spade. It's a construction tool. You can build with that. General positive feedback. I love your code. Every time I read your reviews, it's just brilliant. You're an ace. It's nice. It's lovely to have. It's not useful. It's not actually, I say it's not useful. It's great. It helps build people's confidence. If you think you've got junior engineers that are not quite sure of themselves, but they're creating great stuff, tell them. Tell them it's great. Tell them how impressed you are with the way they're understanding the problem and the way they're building that piece of code. And that really does help. But it's still quite general. It's still fairly non-specific. So it's a heart. I think you're great. The real diamond is the specific positive. I like how you did that. That's really clever. I'd never thought of doing it that particular way, or using this particular, this new way, this new library you've pulled in. That's really useful. Or tell me more about this. We need to work on that. Or how do we get other teams to use that? That's the diamond. That's the real gem. The specific feedback, looking at a particular item that people can work with, giving them the positive feedback on that. That's where they can really build. That's where they can really work. And grow as engineers, as can you, because you've just found something out. You found out for free. It's halfway through a code review. You've just run a tutorial you didn't know you were having. So that's great. Why would you not want that? So I really like this. It was a management-y thing, and I thought that was really useful. On top of that, mentoring and development. I've briefly mentioned that you can help upskill your associates, your juniors, by working with them on particular bits they're not sure or crediting them with things that they've come up with that you didn't see. It's a long time since I was at university. They're bringing new stuff that I'd never heard of. So I'm learning from them too. It's a two-way mentoring and development process. They're learning from sort of the war stories I can tell them, but I'm learning from all the new stuff they're bringing. Never be afraid to raise the question. If you're not sure about something, ask. Put a comment. Say, are you sure about this bit? Or are we sure this is doing what you think it's doing? Now, it probably is, because they've probably spent hours on it. But if you're not sure about it, it's not clear. And in the previous thing, is it readable? Is it quality? Is it maintainable? It's not clear. So ask that question. And even if it's just an area you've not looked at before, or you've not seen that in the wider context, that discussion will help you understand this code better too. So again, 6 months' time, when it's got a bug and you've got to go and fix it, you remember that conversation and you've had that discussion, you've had that context awareness, you've also spread, knowledge sharing is really hard in a team. This is one way of doing it, asking those questions. And also, asking a question about a thing is less directly aggressive and saying, that's just wrong. Because it might not be. You might just have missed it. Ask a question about it. Also, if you've got a nagging feeling about this, and I quite often do this, I'll look at it thinking, now, that doesn't make sense to me. So I'll then go and Google it, and I might spend another half hour looking up this particular piece and thinking, yeah, no, it's right. It's just an area I've never looked at before, or it's a way of approaching that particular algorithm I've never looked at before. So again, I'm learning from this. I'm getting some out for myself. I'm asking these questions. We're all getting things out for ourselves. It's also, we talked about that practical and actionable feedback. Delivering feedback to people. I don't know how many times during a day you get the opportunity to actually talk to somebody and give them some feedback, give them some knowledge that they may or may not want to hear. It's really hard. And if you're wanting to progress up into management, or if you're wanting to get into a senior IC level, you are going to have to talk to more and more people, and you're going to have to, particularly more so in an individual contributor role, if you're wanting to be a staff or a principal engineer, you don't have that line management responsibility. So you can't just say, shut up and do it. I'm telling you to do it because I'm right and you're wrong. Just do it. You can't, I mean, you wouldn't do that anyway because nobody would want to work for that guy. But also, you have no, what you used to call, there's like hierarchical authority. You need to lead by example. You need to lead by influence. You need to bring people with you. You don't shove them ahead of you into the machine gun fire. You're bringing them with you because they trust you know what you're doing, and you're working with them and you're giving that feedback in a caring and sensitive and compassionate, but actionable, specific and honest way. It's hard. This is a practice. Even if you do a code review and you do a couple of small comments every so often, you're exercising those muscles of giving that feedback. You're just practicing so that when you really need to do it in an important situation, you've already got those skills. You've already built those feedback biceps. I talked about knowledge sharing. Every once in a while, when I was young and enthusiastic, I would come up with ways of doing knowledge sharing. We're going to knowledge share today. How do we spread this knowledge? It's really hard. You come up with all sorts of meetings or Slack channels or intranet sites, back when they were a thing. Building a process of sharing knowledge by building a process, having an initiative to share knowledge, it just never works because it's really hard and nobody ever has the time to invest in a process to do that. It needs to grow, and people need to start trusting each other. People need to get used to the idea of being ready and being enthusiastic about saying, I've just found this new way of doing something. Look at this, it's great. Have you tried that? Oh yeah, I have tried that, but I tried this way. Oh, that's good. Yeah, let's do a blend of those two. Code reviewing and the way you look at things and the way you feedback on things, the way people have done it, the way you look for tweaks if somebody's used an old way, or if somebody's touched a piece of code that has an old way of doing something and you want to bring it up to like JUnit 5 or so, some way of improving the frameworks. Doing that through this code review, saying, yeah, we can improve this. We're doing it a different way. It's a way of knowledge sharing without people noticing that the knowledge is being shared. Just all of a sudden, you just all know this stuff. So it's a really, really useful thing to have. I talked about practicing getting that quality feedback. It gives you the opportunity to give credit for good design, but it's also a great way of chipping away at tech debt by pointing it out or spotting something. And even if you don't fix it in that ticket, because you don't want 2 or 3 different changes in the one review, in the one commit. You want one change per commit. That doesn't mean that you can't spot something and raise another ticket for it and have a separate, have a tech debt sprint and sort of pull in all these ones that you spotted from the previous sprint, and you want to improve, and you keep that. You keep it alive, you keep that concept. If you create tech debt tickets from things you spot, and then actually do those tickets, then people believe that you want to improve the quality of that code. People believe you want to bring everything up and keep that code alive and stop it from rotting, stop it from, we've all seen code that has suffered from code rot. If you're tackling that tech debt, you're keeping that code invigorated, you're keeping that code fresh and working, and people are happier to trust that they can maybe allow a bit of debt here because they know it will be repaid. It won't just be like that forever because we never get around to fixing those things. I would also argue that it's worth having guest reviewers. If you've got a particular review, you've got your normal team that you'd ask to have a look at it, pop it to a different team. Ping somebody saying, can you have a quick look at this for me? And in fairness, you'll need to look at some of theirs as well. But share them about a bit. Not all the time, because we all have day jobs, but have a process of inviting guest reviewers to tickets. Bring them in, just say, have a look at it. And they'll be looking for completely different stuff. They probably won't have the context. They might not even know the domain context, but they'll look for different things. And they'll be looking for things within the context of the work they're doing. And this has occasionally been complete gold dust for me, because I was reviewing another team's code, looking at it and thought, wait, hang on a sec. They already have a library for something I'm in the middle of writing. Why am I writing this whole new piece when they've already done it? But because we were in, I won't call them silos, but they were silos, we were working completely independently, and they'd already built at least half of the code I was about to write for the ticket I was writing. And if I hadn't seen that in their review, this sort of out of bounds, I've called it out of bounds communication, we'd never have known. And we'd have wasted all that time rebuilding a thing that, and it obviously wasn't in the code base until they'd committed it. It was really useful. So it saved me a whole bunch of time. They might also be changing something that's going to break what you're about to do, or eventually break it in some weird and indeterminate way. So you're getting some sort of an early view and say, oh, wait, hang on a sec. That looks a bit similar to, can we talk this over? Or tell me more about this. And if you rely on all of the information from one team going to the tech lead, to the engineering manager, to the senior engineering manager, down to your EM, down to your tech lead, down to your team, it never happens. They have so much else to talk about. They're never going to talk. If you can get this side to side, this collaborative conversation between teams about code, you can get lots out of this. And you can build closer relationships between teams. Teams can drift apart really, really easily. This helps keep them closer together. It helps them looking at things in similar ways. Not always, because teams should have that ability to do their own thing within certain parameters. But also, if they're trying something out and you've not tried it before, you're getting free feedback on something you've not spent time doing. So give it some thought. Invite people and offer to do theirs. So, are code reviews worth it? Well, we've looked at different ways of developing, we've looked at different ways of the engineering process, but each of them has a need to review code in some way or other. We've looked at ways to get good quality and reliable and readable code. We looked at ways to develop yourself and mentor yourself and other people and build stronger teams and build more effective teams and teams of teams. And that certainly sounds like a piece of value to me. Thank you very much.